Hello, everybody. We should be live again. This is Klara Widrig, another fellow
Oh
lab
no,
mate of
drop my
mine.
pen.
and so she is currently doing her master's project here at the field lab, working on tinamou musculature. So if you could tell us a few things about that, that would be swell.
Okay, well, I guess I will share my screen. Can you see?
Yeah, I can see.
All right, cool. So this is a poster that I presented at the Progressive Paleontology Conference, I think 2 weeks ago now.
Yeah, I think it was 2
which
weeks
of
ago.
course was virtual.
Right.
But yeah, I am finishing up my MPhil in the field lab, affectionately called the Flock, and I would just like to take credit for coming up with the name Flock. I think it's very important that people know that. But this is what I have been doing for the past year or so. So our lab does a lot of CT scanning, and you can see here the results of my work looking at the musculature of a CT scanned tinamou. But first, I'd like to talk a little bit about tinamous and why they're interesting. Why should I spend a year of my life looking at the pectoral girdle and wing of this one bird carcass? So, tinamous are really interesting because they are the only member of the clade Paleognathae that can fly. So you can see here on this little phylogenetic tree, here are the tinamous up here. This is the one I'm studying, Nothoprocta pentlandii, or the Andean tinamou. Here's what it looks like when it's alive. That photo was taken by our advisor, Daniel Field. And you can see here, this is Dinornithus novozelandiae is the moa. So according to molecular evidence, that is its closest relative. Here we've got the elephant bird and the kiwi bird of New Zealand, the cassowary, and the closely related emu is also there. Then we've got the rheas of South America and the ostrich, of course, of Africa. So that makes up the clade Paleognathae. And all of these big flightless, well, not big in the case of the kiwi, but all the rest are fairly large. All those flightless birds are called the ratites. And for a very long time, it was thought that the tinamou represented the sister group to all the ratites, and the ratites had diverged from each other when Gondwana split apart. So it was like a vicariance type of situation. But in 2008, a really big molecular study came out that showed that that was in fact not the case, and that the tinamous are actually nested really deep within all the ratites. And the implication of this is that the common ancestor of all the paleognaths actually could fly. So that means this ancestor flew to all of the many places in the southern hemisphere where we can now find these big flightless ratites, and independently lost the ability to fly. And then the lineage that led to tinamous was the only one that retained flight out of all of the paleognaths. So that means that tinamous are quite evolutionarily significant. And what we want to know is if we can use tinamou wing musculature to reconstruct what this common ancestor might have looked like. And then furthermore, because the paleognaths are the earliest diverging group of modern birds, or neornithes, if you've been listening to the past few talks from my lab mates, we want to see if we can go back even further and reconstruct what the common ancestor, which would be this node on the tree, of all modern birds would have looked like. So here you see the branch leading to the rest of modern birds, the Neognathae. So that would include the passerines that Lizzie talked about, as well as every modern bird that you can think of that is not one of these species here. So, as is a common theme in the field lab, I did everything using CT scanning, which made it a lot easier to continue working during lockdown because our postdoc, Junia, was able to set up a remote desktop connection to the fancy computer that has all of our CT scans on it, so we were all able to continue working remotely. So he's kind of the MVP of the lab right now in lockdown. So here is what the poor little bird looked like when it was plopped into the scanner, all kind of curled up like a big football. So what I want to direct your attention to first is this last figure right here, figure 8. So this right here is the bird's sternum. And in tinamous, the sternum is really, really long, and that provides a lot of attachment area for the pectoralis muscle right here, which is in pink, and also the supracoracoideus here in blue. So what these two muscles do, the pectoralis is the main flight muscle. It's responsible for the power stroke of flight. It pulls the wings down. And the supracoracoideus does the opposite. It is responsible for raising the wings back in the recovery stroke. And birds have a really cool thing called the Triaceal Canal. So you can see it kind of loops up through here and attaches on top of the humerus. And that canal basically creates a pulley system. So even though the main body of the supracoracoideus is below the wing, it is still able to raise it up, which is really cool. And pretty much, if you tried to raise your arms, you would be using your deltoids. We do not have a supracoracoideus. We're not that special, unfortunately. But what I'd like you to notice about these two muscles is just how big they are. It's quite unusual for them to be that large. Even though these are usually the largest muscles in all birds, the pectoralis can reach up to 40% of a bird's mass, which is pretty amazing. They are notably large in tinamous, and that's because they do something called burst flight. So when you startle a tinamou, it'll usually try to either hide or get away on foot, and they will only really fly as a last resort. They're a bit lazy that way, but they burst into flight. When they do burst into flight, they do it really powerfully and quickly over a short distance. So think of if you startle a chicken or a duck or something like that. Well, a duck's not as good of an analogy as a chicken. Because of the way they fly, they need really powerful pectoral muscles because they have to gain speed really, really rapidly with their short wings. And coincidentally, the reason why chickens and presumably tinamous are very tasty is because they have so much breast meat because of these really large pectoral muscles. But this state of having really large pectorals, a long sternum, and burst flight, we think is really derived. We don't think the common ancestor of all the paleognaths would have had those traits because it would have had to be flying all around the world in order to explain the distribution of modern ratites. We've got Africa, we've got South America, we've got Australia and New Guinea, we've got New Zealand, we've got Madagascar, and then New Zealand again. Mm-hmm. So something like a tinamou would not have been able to make it to all those distant places with its stubby little wings and burst flight. So this ancestor had to have been a more powerful long distance flyer. But we can still use what we've learned here about tinamous to help reconstruct this ancestor because there are some muscles, like the entibicondyle ulnaris, that are present in tinamous, but are not present in neognathae. So we can infer that this muscle was the ancestral condition, that it would have been present in this ancestor and the possible ancestor of Neornithes. And the reason why we've got to look at tinamous for this sort of information is because all of these other ratites, with the possible exception of the ostrich, they still have fairly large wings. their wings are vestigial and they've lost a lot of these muscles. So they're not a very good model for building up this kind of data set. So, and I just wanted to confirm from someone had a question identifying a bird of the Lizzie. I forgot to say this at the beginning, but as someone who lived in California for a total of 3 months, I can confirm that that bird was indeed a scrub jay.
Excellent.
So I hope that answers the question, if that person is still watching the stream.
Right. Very good. So have you finished explaining your poster, or at least what you wanted to talk about?
I think that about goes over everything I wanted to share about the poster.
Okay.
But I've got lots of other things to talk about.
Well.
Fortunately, because I am currently a museum volunteer here at Cambridge. Actually, I will stop sharing my screen now.
But yes, I know you mentioned...
And also, I used to work for the National Park Service, so I've got some good stories from
sure
that.
You do. Yeah. I guess before we go there, I suppose you mentioned that the common ancestor of Paleonates was unlikely to have been a Tinamou, like kind of short distance flyer. And well, what I understand is that we actually have fossil evidence that was the case, don't we? We have a group.
Yes. We do have a group called the Lithornithids that I will be looking at for my PhD, which I'll also be doing in the field lab. So we think those guys are a much better representation of what the ancestral Paleognath would have looked like. They are Paleognaths. They're diagnosed by their jaw morphology, and by all studies that have been done on them, looking at the size and shape of their sternum and the humerus, and in specimens where some of the flight feathers were preserved, so we have an idea of what the wing area was. Every line of evidence points to these birds being fairly adept at long distance flight. I believe that the paper that looked at wing area, the Torres et al. 2019, they came to the conclusion that the best modern analog for the type of flight Lithornithids did was a pigeon.
Which is a pretty damn good flyer.
Pigeons are all around the world. They are perfectly capable of dispersing long distances, as evidenced by the fact that there's unique island species of pigeon. They're able to make it out there. So if you had something like that as the ancestor of Paleognaths, it would make a lot more sense than it being, a Tinamou, which gets exhausted after about maybe 3 minutes of flying.
Right.
That thing is not going to make it across an ocean.
Right. Excellent. So yes, if anyone has questions about Tinamou musculature or Paleonate musculature, please send them in, or Paleonate evolution. I'm sure Klara will be happy to answer them. But otherwise, let's hear some of your national park stories.
All right. Well, the last national park I worked at was Grand Canyon National Park. The other two parks I did some stints in was John Day Fossil Beds National Monument, where I actually worked on canids, so quite different, but still very enjoyable. And Glen Canyon National Recreation Area, better known as Lake Powell, where I was mostly working with ichnofossils and helping them come up with a management plan. Because when you've got all of these fossil dinosaur tracks spread out over a massive area, you have to ask yourself some tough questions about how do you conserve them, because you're not going to be able to physically collect all of them, chisel them out of the rock and bring them into a museum. Some of them are on massive blocks of rock, so it's just not practical to do that. So you have to say, okay, we're going to lose these over time no matter what we do. So we're going to have to find some other way of preserving them, whether it be via photogrammetry or taking casts of them before they weather out too much, and then monitor their degradation over time, make sure visitors to the park aren't vandalizing them, stuff like that. But more about Grand Canyon, 'cause that was the last and not to knock on the other parks, but it was my favorite park that I worked at. Here is a web page that I made in celebration of Grand Canyon's centennial. I was working on a big project to document all the fossil resources within the park. So we have a huge monograph that the chapters are slowly being released as open access. We had to do some work to make sure that the open access document was stripped of all of the classified information about where the fossil locations within the park are. Actually, it's not classified information. It's considered sensitive information by the U.S. government. Right. So we were not allowed to share that. But what we can share these are some specimens that I used photogrammetry to create 3D models of to put online. So these are all housed in the Grand Canyon Museum, and they're not accessible to the public. And we thought that was kind of sad because they're very nice fossils. We wanted to share them, so that's what inspired us to do this project. So to keep this topical, talking about dinosaurs, I will share the California Condor skull. So this guy right here was found in a cave in Grand Canyon. So Grand Canyon has some really amazing Pleistocene cave fossils. Because it's such a dry environment, things can get mummified in the caves quite easily. So here we've got an example. This is, like I said, this is a California condor. We've got some nice little factoids about it. So what's really amazing about these caves, like I said, is their preservation ability. So we've got basically mummified Shasta ground sloth tissue. We have bits of an esophagus of an 11,000-year-old sloth preserved in that cave. We've got chunks of its fur. This particular cave was, when it was discovered, was full of sloth dung that still smelled bad. It was that well preserved. Unfortunately, in the 70s, someone was smoking a cigarette in the cave and lit all the sloth poo on fire, so we don't have that anymore.
Oh no.
Yeah, little sad. But California condors were widespread across all of North America during the Pleistocene because they were specialists on megafauna.
Right.
Well, I guess not really specialists, but that's what drove that most of their ecology was scavenging these massive carcasses. So you think mammoths and giant sloths that provided ample food for these gigantic birds. But when all the megafauna, well, most of the megafauna anyway, in North America went extinct at the end of the Ice Age, their range shrunk a great deal. So most of them ended up living on the Pacific coast, where they were able to scavenge marine carcasses. And there were some still left in the canyons of Arizona because it presented such good nesting habitat. But they were nearly driven to extinction during the 20th century. And it was a really dedicated breeding program that was able to bring them back. All of the condors that were left in the wild were captured and brought into a captive breeding program in the 80s. And as of right now, there are about 500 condors. So that represents a lot more than there was before. They're recovering well, albeit very slowly, because they only lay an egg, in the wild at least, once every 2 years.
Right.
In the captive breeding programs, what they did was they would take the first egg that a pair laid away and raise it by hand, and that would induce the pair to lay a second egg. So they would do this double clutching method to get higher numbers of chicks. But I have some great stories about the condors that are now in Grand Canyon National Park. So I'll come back as a human face, stop sharing my screen to tell you those.
Yeah, sounds good.
Okay, am I back?
Yep.
Cool. So this is my little condor mascot right here.
Yeah.
Her name is 521, and she is named after the infamous man-eating condor of Grand Canyon National Park. So whenever the visitors say that they're going to do, X really foolhardy hike in the middle of the summer, like, oh yeah, I'm going to hike down all the way to the river. And, the rangers say, no, don't do that. It's like 110 degrees at the bottom of the canyon. Please don't. We don't want to have to rescue you. And the visitor says, like, oh, I'm tough. I can, I've hiked in the Alps or like, wherever. I'll be fine. The typical response is, well, the condors need to eat too. And the visitors always think that we're joking, but we're not. The condors in Grand Canyon National Park can and will eat you.
After you're
So
dead,
there is one condor in the park, condor number 521, who has become notorious for scavenging dead bodies in the park. People do a lot of foolhardy things in Grand Canyon National Park, and 521 comes and cleans them up. So usually what happens is several times a year in the park, the wildlife techs will get a call that there is a search for someone who is missing, presumed dead. Can they check where the condors are and see if they're gathering anywhere suspicious? And that has helped the park recover several bodies. So don't do anything dumb in the park. The condors will eat you, is the moral of the story. Please bring lots of water and food if you're going hiking in a national park or anywhere. Do not do anything stupid.
Absolutely, yeah.
That has been my PSA as someone who read all of the incident reports for 6 months every week in Grand Canyon. They're all forwarded to our department.
That is good and reasonable advice. Yeah. Okay, we have a few minutes left, so if you do have any questions about, either tinamous or working in national parks, please send them in.
About museums as well. I'm happy to talk about museums.
But yes, I do remember I have a field guide, maybe you're familiar with it too, on North American raptors, so the modern birds, not the dromaeosaurids. North American raptors called Hawks in Flight. It's a really lovely field guide. Basically teaches you like tips on how to identify all the North American raptors while they're in flight, as it says in the title. And in the chapter on California condor, they actually mention that yes, the California condors are known to hang out near places where there are a lot of visitors congregating. And they added a note, possibly seeing them as a food source.
I can confirm.
Yes.
They are just waiting for someone to drop dead.
Right. Just like they used to follow herds of mammoths and sloths and bison. Now.
The more things change, the more they stay the same.
Yep. So yes, if you have questions about man-eating condors, please send them in as well.
Yes.
Also, I do know that in addition to working on crown birds and outreach, and speaking of large birds, I believe you have worked on a very, very large stem bird that is well known in our community called Tyrannosaurus Rex. Can you tell us a bit about that?
All I'm picturing right now when you said that is, I don't know if you saw the meme that was like, the paleo community if T-Rex had never been discovered, and it was like this beautiful shining utopia.
Oh, right, yes.
There's so many fights over T-Rex. But I feel like I was just kind of poking it with a stick with the research I was doing, because as soon as this gets published, it'll probably just start even more fights.
Yeah. You don't have to go into the details about what you found, but
basically, I was looking at cranial kinesis and the potential for it in T-Rex.
Right.
Which is a controversial topic.
Yes, to say the least. Well, that's very cool. I hope you do get the chance to get that published at some point.
One day in the future, I'll be stirring up fights in T-Rex world.
I know how it goes.
It's not this day. It's probably good if I got at least a master's before I started fights in T-Rex world.
Yeah, I know how it goes. Yeah, I haven't published a lot of my previous pre-PhD work either. Um, yeah, okay. We don't seem to be receiving any major comments, but we are about
Not even about
at
the man-eating condors. Come on, guys, that's cool.
at least from what I'm seeing my colleagues reporting on Discord because I'm not monitoring the chat right now. But yeah, it could be the time of day. In any case, I do think we need to fetch our next guest very soon, which will be our supervisor, Daniel Field. So when we reconvene, that's what we'll do. But thanks a lot for being here, Clara. Thanks
Thanks for
for
the invitation. This has been really cool, and everyone watching should donate.
yes, please do continue to donate. Uh, so yes, I will turn this stream off momentarily, and we will be back soon. Stay tuned.
Bye.